consolidation, data analysis using the Casagrande's logarithm of time fitting method. This is another method to get the coefficients of consolidation. In the previous video, okay, I'm using the same data. I'm using the set of the data. Using the previous video, referring to the previous video, we determine the coefficients of consolidation using the square root time method. For this video, we will determine the coefficients of consolidation using log time method. So we need to prepare the data first for the log time method. So what we need to do is to log the time value. Okay, the time given in minutes, we need to log the value. For example, here log 0 you will have math error. Log 0.04 you will have negative 1.4. Log 1 you will have 0 until log 1440 minutes you will have 3.16. Okay, so once you complete to log all the time value, so now we're ready to plot the graph. So what graph that we need to plot? So prepare a graph with the y-axis is a delta H, the change in thickness. And then the x-axis here is the log time, the value of the log time. Alright. Okay, so ensure that you are able to plot the graph, and then you need to landscape the graph exactly like this. Okay, you prepare this graph exactly like this, and then you will have this kind of curve. It's like a S-curve shape. Okay, and then once you have this plot, so this plot will be used to determine or to identify the T50. T50 is the time taken to achieve 50% consolidations. Okay, remember that in the previous video for the square root time method, we will refer to the T90 to achieve 90% degree of consolidation. But then for this method of log time method, we will refer to T50 to achieve 50% consolidation. Okay, so when you plot, so this is the curve, and then how to get the T50? So the first and foremost, so we need to have a ratio of time. A ratio of time without log that time. Okay, the real value of the time as shown in the data that give the ratio equal to 4. So we need to identify what times of Q, what times of P that will give you ratio 4. So normally it will at the first part of the data here. Okay, so we need to try an error. For example, if you have, for example, here 0.04 over 0, you will get 0. And then if you have 0.25, alright, divide by 0.04, you will have the ratio 6.25. So we want it for the ratio. If you use 0.5, to 0.04, you will have 12.5. And then finally, I think what we can do, we throw it an error. When you have time equal to 1 over to 0.25, you will have that the ratio is 4. So this is what we want. Okay, when the ratio of the time is equal to 4. So we need to identify this point. The point of time is 1 and the time of point is 0.25. Alright, so now what we have here is the log time method. So we need to know. Alright, so for the log time method of 1, for the log time 1, so the value is 0 here. Okay. Alright, so again, so time 1 and time equivalent to 0.25. So the ratio is 4. So we need to find that point. Okay, now time 1 minute. If you log 1 minute, you will have the value of log time is 0. It's here. Okay. And then when you log 0.25, you will have the value is negative 0.6. Okay, so once you identify point Q is here, log time 1 equal to 0. You have the point here. Draw a horizontal line. Okay, and then identify another point of time 0.25. When you log 0.25, you will have negative 0.6. At this point, P is negative 0.6. How we get this is negative 0.6? Because we log 0.25. We log the value of 0.25. Okay, so now we draw another horizontal line through the point P here, exactly like this. And then we measure vertical distance, vertical length of the distance between P and Q, as in the green line. And then we need to mirror this distance. Okay, we need to mirror this distance. And then draw another line. Okay, in a pink color, that one indicate for U equal to 0%. So this is where U equal to 0%. So ensure that the vertical distance of P and Q, okay, and then you mirror this vertical distance to get another horizontal line here. So that line will indicate of U equal to 0%, the degree of consolidation at 0%. So at the change in thickness of 0.08 mm. So how to get 0.08 mm? You just read from your y-axis here. Okay, so this is how we get the U equal to 0. Okay, now once we have U equal to 0%, so next, look at the below part of the curve, at the bottom part of the curve here, you will need to draw another line at the straight portions of this curve. At the bottom part here, draw an extension of the straight line here. And then we will need another straight line tangent to the curve part in the middle part here. And then you will have an intersection between these two lines here in the green color and the brown color here. Okay, so this is an intersection point here. Alright, so from this intersection point, draw a horizontal line. Draw a horizontal line, and this is the line for U equal to 100% degree of consolidations. So it's located at the change in thickness 1.23 mm. Alright, so now this is the U for 100% degree of consolidation. Okay, now our objective from this plot is to get the T50. Now knowing the U naught and knowing the U 100%, we know that the T50 will located in between these two lines. But then how to get the exact locations of the U 50%? So we can use these calculations. Alright, because we want to know where is, at what change in thickness of the 50%. So the delta H 100%, 1.23, minus with the delta H naught, 0.08, divided by 2 because it located in between. And plus with the delta H naught because we want to know the delta H naught for U 50%. So by calculation, you will have the delta H at 0.655. So identify where is 0.655 and then you draw a horizontal line at delta H 0.655. So that is for the U 50%. So knowing that this is the degree of consolidations for 50%. Alright, so we want to know the T50, the time taken to achieve U 50%. So now we know that this is the line for the U50. So there is an intersection point here in between the pink color here with the curve that we plot. Okay, with the curve that we plot. So there is an intersection point, okay, from the intersection point going up and then read the value at the x-axis here. Alright, so it's here around 0.51 minutes. So this is the value of log t. So we want the real t. So how to get the real t? So we need to anti-log this value. We need to anti-log this value by pressing shift log on the calculator and you will have this value 3.23. This is the actual time in minute for T50 to achieve a U equal to 50% degree of consolidation.